Chapter 12, Section 1, Arithmetic Sequences and Series. Yes, that looks like arithmetic, but it is pronounced arithmetic. As with any other Section 1 of any chapter, this is going to be kind of heavy on vocabulary. This kind of lays the foundation for the rest of the chapter. So the first vocabulary term in 12.1 is sequence. A sequence is simply a function whose domain is the set of natural numbers. Remember, the set of natural numbers is all the positive integers, does not include 0. So the numbers you first learn to count when you're a little kid, 1, 2, 3, 4, all the way up forever. The terms of a sequence are each individual element of a sequence. So this one would be the first term, and then the second term, and then the third term, and then forever going up. Okay. When we're notating terms, the first term is denoted by a sub 1. So we're using subscript just like you would in chemistry. Okay, so first term is a sub 1, second term would be a sub 2, and the nth term, whatever term we wanted, the 50th term, the 12th term, the 17th term, the 100th term, whatever it might be, the nth term is denoted by a sub n. Okay, in an arithmetic sequence, what makes a sequence arithmetic is it's a sequence where the difference between any two consecutive terms is a constant, or it's the difference between any two consecutive terms is the same. Okay, so if we count by twos, that would be an arithmetic sequence. If we count by, fives or halves or thirds or whatever it might be, that's what makes a sequence arithmetic. Okay, the number that is between each two consecutive terms is called the common difference. The common difference is the constant between any two consecutive terms in an arithmetic sequence. So let's just say I had 2, 4, 6, 8, and so on. The common difference here would be 2, okay, because between each of these two terms is 2 number, or the difference between the two, each two consecutive terms is 2. So the common difference in that example would be 2. Okay, let's try a couple of examples here. Let's find the next 4 terms in each sequence. It's going to help to find the next 4 terms if we knew what the common difference was in each of these sequences. Let's start with number 1. So the common difference is equal to, well, if we go from 5 to -2, that's up 3. And then from -2 to 1, that's also up 3. And 1 to 4, that's also up 3. So we can say the common difference is 3. Okay, so the fifth term, because this gives us the first 4 terms, so the fifth term, so a sub 5 is equal to, we're going to use our last term, 4, and we're going to add 3 to it, so 4 plus 3, that would be 7, and we're just going to keep continuing the pattern. The sixth term, we'll take the last term that we just came up with, add 3 to it, and that would give us 10. The seventh term here would be 10 plus 3, or 13. And then the eighth term, I think you could figure it out. We go 13 plus 3, and that would give us 16. Okay, for the second one here, 10, -1, -12, and so on. Looks like I'm going down this time, so 10 -1 would be -11, and it's entirely possible for your common difference to be negative. It's entirely allowable. I'm just going to abbreviate here. CD, common difference, is equal to -11. So instead of adding 11, we're going to subtract 11, or you could think of it as adding -11. Either one is fine. We have the first 3 terms, so our first term that we're going to find is the fourth term. So a sub 4 is equal to, we start with the previous term, -12 minus 11, that gives us -23. Then the fifth term, we're going to have -23 minus 11, and that's going to give us -34. And then the sixth term would be -34 minus 11, that would be -45. And the seventh term, a sub 7, is equal to -45 minus 11, and that would give us -56. So there's the next 4 terms in each sequence. Rather than writing out each individual term the way we just did, what we can do is we can use what's called a recursive formula. Recursive formula, another vocabulary term, it's a formula used to determine the next term of a sequence using one or more of the previous terms. Okay, it's kind of a mouthful. Basically, you're using original numbers or older terms to figure out your next terms. In an arithmetic sequence, there is a formula for it. It looks like this. So a sub n is equal to a sub 1 plus d times n minus 1. Now, we have lots of variables going on. The n, these are not going to change. Okay, well, they might, but in terms of if you were asked to write the formula for a sequence, you would leave these n's. The ones you're going to fill in are the a sub 1 and the d. Okay, so what do each of these terms represent? Well, the a sub n, that represents the nth term of our sequence. Okay, we don't know what it is. It could be the 5th term, it could be the 12th term, it could be the 100th term, it could be the 41st term. We don't know. Okay, so the a sub n represents the nth term. A sub 1, like we said earlier, that represents the first term. Okay, that's the first term. D represents the common difference. Common difference. There it is, and that is what the D represents. Now, the n minus 1, that's the recursive part, using the one or more of the previous terms. So if this is the 12th term, we're going to find the 12th term using the 11th term, n minus 11. Okay? That's how this is going to work. So let's try using this formula to find the 41st term in the sequence. We've got a couple of examples here. So the first one, -4, -1, 2, and then 5. So if you look, it looks like we're going up 3 every time. So the -4 to -1, that's up 3. -1 to +2, that's also up 3. 2 to 5, again, up 3. So what we can say is that our D value is going to be equal to 3. We're going up 3 every time. Okay, we know the first term, it tells us a sub 1, our first term, is -4. And now we can use this information to find any term in the sequence. Specifically, this time we're looking for the 41st term. So let's fill in what we know. We're looking for the 41st term, so we're going to say a sub 44. The 44th term, not 44, sorry, 41. 41st term is equal to our first term. If you go back to the formula, first term, so -4, wrong variable. First term plus the common difference, so plus 3 times, again, n is 41 this time, the whatever term we're looking for, minus 1. Now this is just a matter of doing arithmetic and following the order of operations. So we can say -4 plus 3 times 41 minus 1 is 40. So -4 plus, this will be 120. And we can say now that the 41st term, a sub 41, is equal to -4 plus 120 is 116. So instead of writing out the first 41 terms of this sequence, which would take forever, what we can do is we can use this recursive formula. We know the 41st term is going to be found by using this information, and let's just run it through and use arithmetic to get 116. Let's do the same thing with number 2 here. We need to find the common difference. Common difference is, let's see, we go from 11 to 4, that's down 7. 4 to -3, also down 7. -3 to -10, again, down 7. So our difference, our common difference is -7. We're going down 7. The first term, a sub 1, that would be the first term in our sequence. That's 11, this one right here. And we can fill in what we know. We're looking for the 41st term, so we can say a sub 41 is equal to our first term, which is 11, plus, and in this case I'm actually going to make this minus because our common difference is negative, so minus 7 times, again, 41 minus 1, because our n value is 41. If your n value was something different, 44, 50, 100, 130, whatever, then these two numbers are always going to match. Okay, so let's just run this through. So we're going to say 11 minus 7 times 40. 7 times 40 is 280, so we'll have 11 minus 280, and we can say that the 41st term, a sub 41, 11 minus 280 is -269. Again, rather than writing out all 41 terms or the first 41 terms of this sequence to figure it out, we can use our recursive formula to easily and quickly find the 41st term. Now, what if I told you something different? What if I gave you the 19th term or the 44th term, like I have in these two examples here, and I said, find the first term? We can do the exact same thing. We just need to solve for a different variable in our formula. Okay, we're given the D value, we're given the 19th term in this first example, so we can make our n value 19, and the only thing we aren't going to know is the a sub 1. So if we remember the formula, a sub n is equal to a sub 1 plus d times n minus 1. Well, obviously, this is going to go right there. A sub 19, this part will go right there, and then this n and this n is going to be 19. So let's fill in what we know. We know the 19th term is 42, okay? So this whole thing replaces this whole thing. So 42 is going to be equal to a sub 1 plus your d value, your common difference is negative, so I'm going to make that minus 2/3 times your n value, which was 19, whoops, not 13, 19 minus 1. And let's solve for a sub 1. 19 minus 1 is 18, so 42 is equal to a sub 1 minus 2/3 times 18. 2/3 of 18 is 12, so we'll say 42 is equal to a sub 1 minus 12, and all we need to do is add 12 to both sides, and we can say that the first term in our sequence is 54. Let's do the same thing for number 2 here. So we're going to start with the formula. So our a sub n, or a sub 44, this time is 229. So I'm going to skip the line in purple, but everything fits just the same way. 229 is equal to our a sub 1, we don't know what the first term is, plus our common difference of 8 times our n value, n this time is 44, because we're given the 44th term, again, minus 1, and let's solve for a sub 1. So 229 is equal to a sub 1. 44 minus 1 is 43, so we'll say times or plus 8 times 43. 8 times 43, if you type that in the calculator, what you're going to get is 344, so a sub 1 plus 344. And again, just a simple single step to get a sub 1 by itself. The first term in this sequence is negative 115. The title of section 12.1 is Arithmetic Sequences and Series. Well, we haven't really talked about what a series is yet. Okay, so an arithmetic series is the sum of the terms of an arithmetic sequence. We'll be looking for a specific number of terms because arithmetic sequences are just going to get bigger and bigger and bigger, or smaller and smaller and smaller as we go. So what we're looking for technically here is a partial sum, and the partial sum is the sum of the first n terms of a series. And the notation for a partial sum is capital S with a subscript of n. Okay, so the partial sum is the first n terms. So if I wanted the first 15 terms, it would be s sub 15, or if I wanted the first 20 terms, it would be s sub 20, something like that. An arithmetic series does have a formula to find the sum of. Rather than just listing them all out and typing them all in the calculator, there is a formula for an arithmetic series for adding up the first, n number of terms, whatever it might be. And here's what it is. The sum of a finite, meaning it has an ending point, okay, goes like this. S sub n is equal to, we're going to take n over 2 times a sub 1 plus a sub n. Now, you are going to know the first term, and this will end up being the last term in your sequence. If we want to know the sum of the first 12 terms, well, this will be s sub 12 is equal to 12 over 2 times whatever your first term is plus whatever your 12th term is. Okay, remember a sub n stands for whatever the nth term you're looking for. Okay, so let's try an example here. Find the sum of the first 32 terms of the arithmetic series. Negative 12, negative 6, 0, and then goes on down the line. The last term, the 32nd term here, is 174. Okay, in order to find the sum of this, we need to know three things. We need to know the n value, which we have, 32. We need to know the first term, which we have as well, negative 12. And we need to know the last term, which we also do, 174. This is the 32nd term in our series, 174. So once we have this information, we can actually just plug this into our formula, and it works itself out pretty quickly. So we're looking for the 32nd, the sum of the first 32 terms, so s sub 32 is equal to, again, our n is 32, so 32 over 2 times our first term, which is negative 12, plus our last term, 174. And this is something you can type in the calculator. If you want to make this 16 and want to make this 162, you can. If you want to just type it in like this in your calculator, you certainly can. I would just say maybe make sure that's in parentheses, and then just figure this out. This is something you can type in your calculator, going to be 2,592. So again, a lot faster than having to write out the first 32 terms. We know the common difference. If we look at it hard enough, we would figure it out. It's 6. If we want to list it out, the first 32 terms, and find pairs that add up nicely together, we could do that, or we could just use this formula here and get our answer rather quickly.